Hello, welcome to A Physics, a complete class note series. In this video, we learn dialectics and their polarization. Dialectics are insulating materials which does not allow the flow of charges through it, but permits them to exert electrostatic force on one another through it. That is, they transmit electric effects without actually conducting electricity. What is the meaning of this? We broadly classified all the substances into two groups, conductors and insulators. Here we are saying insulator as dielectrics. Through the dielectrics, no electric current can pass because there is no free charge carrier in the dielectrics. But electric field can transmit through the dielectrics. There are two types of dielectrics, nonpolar dielectrics and polar dielectrics. Now let us see what will be the behaviors of these polar and nonpolar dielectrics when they are subjected to some external electric field. Nonpolar molecules. What is the meaning of the nonpolar molecules? A molecule in which the center of positive charges coincide with the center of negative charges is called a nonpolar molecule. That means we know all the molecules made up of atoms, and within the atoms there are electrons, protons and neutrons. Electrons, they are revolving around the nucleus, and the protons, they are staying within the nucleus. And one molecule, it is made up of one or more than one atoms. Therefore, there are positive charges at the nucleus and negative charges of electrons which are revolving at the different circular orbits or different types of orbits. Just like center of mass, there is a center of charge also, center of positive charge separately and center of negative charge. For the some symmetric molecules, these two centers, center of positive charge and negative charge, they are coinciding to each other. These type of molecules are nitrogen, CH4, O2, C6H6, etc. In such a case, the center of negative charge particles, that is electrons, and the positive charge particles, that is all the positive charges at the different nucleuses, these two center of charges coincide to each other. There is no separation between these two center of charges. That means there will be no net dipole moment, since two equal and opposite charges within the molecules, but there is no separation between two center of charges. Net dipole moment is zero. In the absence of external electric field, the effective positive and negative centers coincide, and hence dipole is not formed. That means there is no net dipole moment, and molecule of these types, there are net no dipole moment because the positive center of charge and negative center of charge, they coincide to each other, and due to the symmetrical shape. And now what will happen if these molecules or these type of dielectrics, whose molecules are non-polar, are placed some external electric field? In this figure diagram, let us suppose E is the applied or external electric field that is applied on this type of dielectrics. Now we can consider for each and every molecules, due to the action of this external electric field, center of negative charge, they are subjected to some force opposite to the direction of electric field, and positive charge in the same direction of the electric field. Therefore, there will be some separation between the positive center and negative center of charges. Two equal and opposite charges, they are separated by a small distance. That means a dipole moment is developed under the action of this. Now positive charge is shifted in this and negative in the opposite directions. So when electric field is applied, the positive charges are pushed in the direction of electric field, and the electrons are pulled in the direction of opposite to the electric field. Due to separation of effective centers of positive and negative charges, dipole is formed. And it is known as the polarization of the non-polar molecules when these are subjected to some external electric field. It is one type of polarization effect. Initially, molecules are non-polar, and when they are placed in any external electric field, they become polarized, and this phenomena is known as the polarization of dielectric. Now, polar molecules. A molecule in which the center of positive charges does not coincide with the center of negative charges is called polar molecules. Polar molecules do not have symmetrical shape. Example: HCl, H2O, NH3, CO2, alcohol, etc. Here, the example of the water molecules, there are two bonds, OH bond, another OH bond, and 105-degree angle between the two bonds. That means we can consider it is one dielectric and it is another dipole, it is another dipole, and they are placed in this way. And therefore, net dipole moment that is not equal to 0. Simply, when the center of positive charges and negative charges, they are not coincide to each other. That means already there is a separation, and therefore they possess some dipole moment. We know that dipole means when two equal and opposite charges separated by a small distance. So already they have some dipole moment. And if you look this figure diagram, it is one molecule, net dipole moment, negative to positive directions, arrow headed. Here, in the absence of external electric field, the permanent dipoles of the molecules orient in random directions, and hence the net dipole moment is 0. Now one question is, since all the molecules they possess dipole moment, therefore if we take a sample of this dielectric, is it a dipole, just behave like a electrical dipole as a whole, or no? Why it is no? Now, due to the thermal agitations, these dipoles are not oriented in the same directions. They are randomly oriented. That means their directions of the dipole moment are different. And as a result, their vector sum is 0. And as a whole, the piece of the sample of dielectric do not show any net dipole moment. But when these are subjected to some electric field E, external electric field, when electric field E is applied, the dipole orient themselves in a regular fashion, and hence dipole moment is induced. Complete alignment is not possible due to thermal agitations. And what is the meaning of this? Now, when these molecular dipoles are subjected to some external electric field, and we know from our previous knowledge, when any electric dipole is placed in a uniform electric field or any electric field, always they experience a torque, and that torque try to set themselves parallel to the external electric field. That means this external electric field try to make parallel them, that means align them, but it is not possible that all the molecules will be along the same direction, because thermal agitations also present here, and ultimately you get the some dipole moment as a whole, and the polarization is taken place, and here the net dipole moment will be obviously more than the dipole moment of the non-polar molecules when they are placed in the same electric field. Now we can see the dielectric in another way. Generally, a non-conducting medium or insulator is called a dielectric. Precisely, non-conducting material in which induced charges are produced on their faces on the application of electric field are called dielectrics. In our previous slide, we learned that what is the dielectrics. Now, no electric current can pass in through this. Only the electric field can transmit through this. These materials are known as the dielectrics. And here another interpretation of the dielectrics. What is this? Now, the non-conducting materials in which induced charges are produced on their faces on the application of electric field are called dielectrics. Example of dielectrics already we know: air, H2O, glass, mica, paraffin wax, transformer oils, etc. Polarization of the dielectrics now. When a non-polar dielectric slab is subjected to an electric field, dipoles are induced due to the separation of effective positive and negative centers. Initially, there was no dipole moment, but separation taken place due to the influence of external electric field, and dipole moment developed, and it is known as the polarization. But in case of the polar molecules, the already dipole moments are present and they are aligned themselves. Therefore, you get more dipole moment in case of the polar dielectrics rather than the non-polar dielectrics. E naught is the applied electric field. Let us suppose that is external electric field. It is E naught. It is positive charge plate. It is negative charge plate, and there is a electric field, that is the E naught, from the positive to negative charge plate. And due to the polarization, opposite electric field, that is the EP. EP due to the polarization is developed within the dielectrics, and now net electric field within the dielectric, that is less than the applied electric field. The net electric field En equal to E naught minus EP. That is, the field is reduced when a dielectric slab is introduced. The dielectric constant is given by now. There is a electric field when there is no medium, and electric field, reduced electric field, when this dielectric is placed in that electric field. And from our previous knowledge we know it. And dielectric constant K, or relative permittivity, it is also known as. And dielectric constant K here, E naught divided by En. En means reduced electric field. In case of the polar molecules, EP will be more. That means the denominator will be less and the value of the K will be more. And therefore, we are observing the dielectric constant for the polar molecules like water. It is quite larger than the non-polar molecules. Polarization factor, one term related to it. The polarization factor measures the degree of polarization of the dielectric. It defined as the dipole moment of the unit volume of the polarized dielectric. That means dipole moment, net dipole moment is developed both in cases of the polar and non-polar dielectrics when they are subject to some electric field. Now, what is the net dipole moment developed per unit volume? N is the number of atoms or molecules per unit volume of the dielectric. Then polarization factor is capital P factor is equal to N. N is the number of molecules per unit volume into small p. What is the small p? The dipole moment per molecule developed here or already staying. SI unit of polarization vector is Coulomb per meter square. Another interesting term, that is the dielectric strength. What is dielectric strength? Now, dielectric strength is the maximum value of electric field intensity that can be applied to the dielectric without its electric breakdown. Now, let us suppose one dielectric that is subjected to some external electric field, and gradually we increases the electric field. What will happen? Polarization taken place, and again we are increasing, and what will happen within the dielectrics? After a certain value of the electric field, applied electric field, external electric field, there will be breakdown. That means the dielectric also will be ionized, and suddenly very large amount of current will pass through it, and it is not the electrical breakdown. So what is the unit of the dielectric strength? Now, that is nothing but the unit of the electric field, and in SI section there is volt per meter, but in our daily life it is used, practical unit is the kilovolt per millimeter. And there are some dielectrics in this list. The vacuum, the dielectric strength is infinity because there is no molecules or ions in the vacuum to be polarized or for the breakdown to produce the charge carriers within the dielectric. Here it is 0.1 to 0.8 to 1, that is porcelain, that is 8 to 428, pyrex, that is 14, paper, that is 14 to 16, rubber 21, mica, that is 160 to 200 kilovolt per millimeter. And you can see the effect of this dielectric strength when any circuit, any junction of the circuit is loosely connected, at that sparking taken place. Why spark? Here it is dielectric as a whole, it is insulated, but when a very high electric field is applied to the air, at that time the breakdown is taken place, and this breakdown volt electric field is known as the dielectric strength, and it is about 0.8 to 1 kilovolt, 1000 volt per millimeter. and when it is breakdown, charge carrier produced and electric current passes through it, and we observe the sparking. Now it is the end of this topic, and you get this text in the link given in the description box. You wait for the next video, and you subscribe this channel, then you will get automatically the update or new video loaded when in this channel. Thank you.